Okay, I hope that this is gonna be over quick because I don't like how I sound right now. Okay, so for the next part right here, we're gonna write a rule for g of x. It just means that we're gonna write a new function called g of x, and it's gonna follow this function rule, but with these transformations right here. Okay, so the first transformation it's telling us to do is a vertical stretch by 3. I really recommend that you guys know how to write your notation. So a vertical stretch by 3 is 3 times by f of x. Okay, so what that means is 3 times by f of x. If I were to apply that to this side of the equation, it would be 3 times f of x. So 3 times by x squared, sorry, I'll write g of x here, 3 times by x squared minus 3x plus 1. Then I distribute 3x squared minus 9x plus 3. That's the first one. Translation 3 units down. That is f of x minus 3. So what that means is I'm going to subtract 3 from the function. Remember that this is the function where I left off. So I'm going to subtract 3 from it, just like the notation shows right here. These are going to cancel. So when I simplify it, I get g of x is going to be equal to 3x squared minus 9x, since those canceled. Okay? Next, the last one is followed by a reflection in the y-axis. The notation for this right here is f of negative x. Okay, so I'm going to remove where x is located. I'm going to remove that with negative x. Okay, so g of x will be equal to 3 negative x squared minus 9 negative x. If it's negative x squared, let me show you up here what that will turn into. Negative x squared with the negative inside the parenthesis is the same thing as negative x times by negative x, which is actually equal to positive x squared, since negative times negative is positive. So this is just going to simplify to be positive 3x squared. Here, I have negative x times by negative. Since this isn't being squared, then negative times negative will be positive, so positive 9x. And there you go. You applied all transformations here to find the new function rule. Determine if the function is even, odd, or neither. So here is a step-by-step process on how you can find it. First, start by finding f of negative x. So this means right here, just like we did over here, where we applied this notation here is a reflection in the y-axis. So plug in negative x. So I plug in negative x into the function. I'll do that down here since I have room. Negative x to the fourth minus 4 times by negative x squared plus 1. If I simplify, again, this is an even power, which means the negative will eventually be multiplied to be positive, so this will be x to the fourth. Same goes for this expression right here, where I have negative 4. The negative x squared will just end up being x squared, then plus 1. So here I have x to the fourth minus 4x squared plus 1. Okay, next is to find negative f of x. Negative f of x is a reflection in the x-axis, which means I'm going to take this function, multiply it by a negative, and distribute. So that means every term will change its sign. So negative x to the fourth plus 4x squared minus 1. Use parts A and B to justify if the function is even, odd, or neither. Okay, well, if it's an even function, then part A will be equivalent to the original. And since it is an even function. So we can go ahead and fill that in. This is an even function. If it wasn't even, we'd check and see if it's odd. If it's an odd function, then negative f of x will be equal to f of negative x. These will be equivalent. Since they are not, it's not odd. If this function is not equivalent to this one, if this function is not equivalent to this one, then it would be neither. Let's try the next one. So I'm going to check and see if it's even by part A. So I'm going to plug in negative x where x is. So negative x to the third minus 1. Well, if I have a negative multiplied by itself 3 times over, that's still going to be negative. So negative x to the third minus 1. Since this function right here is not equivalent to what I had before, it's definitely not even. Let's check this other one. negative f of x. So again, I'm going to multiply the entire function by negative, so I'm going to distribute the negative. Negative x to the third plus 1. Okay? If this function is equal to this one right here, it would be odd. Since it is not equivalent to the one here, it is not odd either. So therefore, since it's not even, it's not odd, it's neither even nor odd. There you go. Okay, so for this one right here, we're going to graph the function. Notice that this is an intercept form. So it's an intercept form, so each of these factors indicate a intercept and a solution. So I take each factor and set it equal to 0, except for 2, because I cannot set 2 equal to 0, since 2 cannot be equal to 0. So I say x is equal to 0. There's one solution. X plus 2. Set that equal to 0, solve for x, I get x is equal to negative 2. Note that this factor occurs twice since it's squared, so this 0 will also occur twice. That's going to be important when I graph. Then I have x minus 1. I set that equal to 0. I get x is equal to positive 1. So here are my three intercepts. Also note, this factor right here is 2 degree 1. This one's 2 degree 2. This one is 2 degree 1. So if this is degree 1, degree 2, degree 1, if I add those degrees together, I get 4. So this function will be degree 4. And it has a leading coefficient of 2, and it's positive, so the leading coefficient is positive. So I have x-intercept at 0, I have x-intercept at 1, and at negative 2. That means from this point right here, it's going to have to, since it's an even degree and it's positive, both ends have to be going up. So from this intercept, function has to be going up. If it were negative, it would be going down. If it were of degree 3 and positive, it would be going up here and down here. If it were odd and negative, it'd be up here and down there. So those are rules from 3.1 from the previous unit that we did. Also note that this is happening twice, so at this one, it's going to have to bounce, since that is occurring twice. So we'll draw that right there. Okay, and then here, it's going to have to cross, because at x equals 1, it only occurs an odd amount of times. And since I don't really want to plug in a decimal, I'm just going to go down a little bit, go back up, and it's going to have to cross right there. However, I'm going to test negative 1 into the function to see what I get, so I know how far I can go up, or I get an idea. So if I plug in negative 1, I'll get negative 1 for that one. I'll get negative 1 plus 2 squared. I'll get negative 1 minus 1. 2 times negative 1. Then I'll get 1 squared. Then I'll get negative 2. So I'm going to get negative 2 when I multiply those together. This right here, 1 squared is 1, and that's going to be negative 2. Then negative 2 times negative 2 is going to be positive 4. So that's where my point could go at least as high, if not higher, and then fill in the rest. So there you go. That's going to be a sketch of your function. In this last problem right here, we're just going to use the graph here to estimate everything happening here. So estimate the x-intercepts. So here's an x-intercept right there. That looks like it's at negative 1.5. So say x is equal to negative 1.5. Another one right here, that looks like it's going to be less than a half, so maybe 0.4, 0.3, something like that. So x equals 0.4. And this last one right here occurs at 2, so I'll say when x is equal to 2. The local maximum, that's right here. That appears to have a coordinate point somewhere about like right here. That looks like it's negative 0.75 maybe. Comma, the y value appears to be maybe like 13. So there's your local max. For the local minimum, that's down here. That appears to be somewhere close to maybe 1.25 or something like that. And the y value appears to be somewhere about negative 11. There you go. Increasing. So for increasing, looks like it's increasing here and here. So that looks like it's going to be to the left of this point right here. So it's increasing to the left of whatever x value I stated for my maximum. So I'm going to say x is less than negative 0.75 or negative 0.75. The other interval of increasing happens to the right at this point right here. So that's going to be to the right of the value of my minimum, which was right here. So I'll say x is greater than 1.25. Decreasing. So the function is decreasing in between those. So it's decreasing right here. So that is going to be in between my max and my min. So I'm going to write x is less than. The lower bound is negative 0.75, which was the maximum. And then the minimum, it went to the minimum, which was 1.25. So between these two x values, that's where it's going to be decreasing. Okay, and I've covered every question for the review. Hope it helps.